Welcome back to our gate building series. If you just found us, you need to know we've already posted several videos covering the design, the excavation, the concrete, and building and installing the columns that are going to be holding all this square tubing in place. You might consider dropping back to catch up on the series before you go ahead and watch me weld this thing together.
I think I've done all my homework on the latch, the housing for the electromagnet. I think I got that dialed in. I think I've got the length of the gate figured out, so I've got plenty of room. This is one time when I don't want the carpenter in me to cut it too tight. Can't have that. And I think I've got these hinges located properly on this gate hinge style. So, all that being said, hopefully all of it being true, I've got these things lined up in a plane. I'm going to tack them down and then just verify, put a straight edge up against them and make sure that when it comes time to drop the gate into the hinges that they actually fit. Well, I had to head off a little mistake here, or what would have been a mistake if I hadn't caught it. And that is, so I ran this bead right across the top of this hinge before welding the sides. They turned out okay. I think they're strong. Stronger than the factory connection right there between the barrel and the bracket. But when I ran that bead right here across the back of that cope, it shrunk and it twisted this up right here about, you know, it raised that up because this shrunk right here, pulled it up like a lot, like maybe 1/8 of an inch. And so now was the time to catch that. It's something to keep track of, that anywhere you put a weld or a bead, it's going to want to shrink that metal. The part that gets hot gets small when it cools off. And I hope to use that to my advantage when I bend the brace for this gate. We'll see how that works out. All right, I got this thing in here. The dimensions are good. It's flat, it's square, and now I want to rack it so that the strike side, you know, 15 feet away from the hinge, is lifted up, I don't know, maybe 1/4 or 5/16, because gravity's going to want to pull it down, and I want it to start out just a little bit high so that the cumulative flex, you know, and steel over that distance, you know, encouraged by gravity, at least has a head start before it comes to rest, wherever it comes to rest. Is this necessary? I have no way of knowing, but Greg recommends it. It makes sense to me. I'm going to do it. "5/16". So that's where it was, nice and square, uptight against that little piece of 1/2 by 2. Same thing right down in there. Had it held where it goes on the end. So what we're creating is a parallelogram. These corners were held down pretty well. Time to glue this thing together.
Probably 95% of the welding that happens in this old shop is with this Miller-Matic 210. I bought it used about 12 years ago, I think, and as I remember, I paid $1,200. It's a solid, reliable workhorse, and I just love it. This machine is one of the very last solid-state, transformer-based MIG machines that Miller made. The constant voltage adjustment is done with a mechanical ring switch. There's almost nothing electronic or digital about this whole thing, and so it just runs and runs and runs. It's a smooth, controllable, reliable machine that has plenty of power for my needs, and I'll tell you what, once you've MIG welded, it's not much fun to have to go back to a stick machine. Square tubing, rectangular tubing, tubing in general comes from the steel mill, heavily oiled. It's a real mess, but it's fairly well protected from rusting at least for a while. But the grease has got to go off of these things, and I use a non-chlorinated brake cleaner just to make life easier and steel cleaner. But the non-chlorinated part is a huge deal, because a chlorinated solvent left on the surface of the steel and welded into with a welding puddle, at thousands of degrees of temperature, combined with the argon in the shielding gas, can create a nerve gas. Now, I don't know if it's phosgene or what it is, but I know this: if you make this mistake, and if you inhale that stuff, it can kill you in a hurry. So you remember the heat shrinking dynamic that I was talking about earlier when I had to straighten out the last little ear on that coped joint? Well, when I'm welding these pickets in place on these 3x3 tubes, I'm just tacking them lightly and then coming back and welding them in an alternating pattern. Sort of like when you tighten the lug nuts on your car's wheels, you alternate across the center of the wheel in order to tighten it up sort of uniformly. Because I don't want to stress a bend into these long, straight rails. And besides that, I have to pay close attention to all of this because these 20-inch openings must remain really close to perfect also.
So it's a little hard to make this out, but what we have now is the main frame, and I've racked this corner up about 5/16 high. The hinges are welded to the gate frame. We'll weld to the posts when we actually take the gate out. This side is not right. I haven't drawn in these intermediate pieces, but they will go just like this, the way they are in place right now. And what you're watching me put in now is this top rail, and I'm having to suspend it with cantilevered pieces of tubing so that I can get both the lateral, I can get both distances. X and Y can be held in place, I hope, fairly perfectly, because these lines would be easy to see if this is not straight from top to bottom. There's left and right. Here is up and down. I'll start cutting the pieces and just putting them in place. Ken, is this going to work? Of course it's going to work. All right, I've got the two ends captured. I'm going to capture this with the right spacing, clamp everything down, line everything up, and then just kind of run on through these, I think. I've been sorely testing Kenny's patience because, at least when I'm fabricating, it is quite a bit like watching paint dry. And the paint's all the same color. And he says he's had about all he can take. Who could blame him? This is the last piece of tubing I've got to put in this thing. I put a couple of spacers in here, 20-inch spacers. Didn't try to chalk a line, didn't try to do anything to get it straight, except use the same spacers off of the line that I know is straight, which is that top rail. And then, yep, it went in. Slide it under here. Make sure it's up against the spacer. Make sure it's up against this device. And clamp it. Tap, tap. Make sure we're flush. Make sure we're up tight. And I don't have to get a tape measure, I don't have to check anything except that it is up against the jig that went with me all the way down. So this thing is just about lightly tacked together. And the way that I look at that is that all four corners of all of the intersections of the 2x2 pickets and horizontal pieces with the 3x3, the stiles and rails around the outside is all tacked together pretty good. All the corners, enough to keep it there. And then I'll go back and weld probably the vertical welds on where the pickets intercept the rails, because heat shrinking is a thing. When you get something hot, as it cools, it tends to end up shorter than it was when you started. And if that happened all the way down one edge along the top of one of these tubes, you might want to bend if it wasn't restrained by the identical tube on the other side. So I'm going to alternate corner to corner, kind of keep it in mind, and keep my beads as small as I can. Even though I'm not a great welder, try to hold the bead size down so we're not pumping a whole bunch of heat into the corner of these square tubes. Now we're going to be using heat shrinking, hopefully, towards the end of this fabrication process, and I'm loading my gun for that. All right, it's lightly tacked. Now I'm going to tack it with the vertical welds in all of the corners everywhere, and then come back and run the horizontal stuff on the top.
So another advantage to MIG welding is that a vertical weld, which is half of what I need to be doing here today, can be done running the bead downhill. But with a stick machine, that is a no-no. You've got to push the weld against gravity to make it strong, and so it never looks that good. But with a MIG gun, downhill is just fine. Well, it turns out that when I built this platform to put this gate on, I missed an important calculation, and I made it about 2 inches too high to be able to hook the top of the gate with the crane, lift it up, and turn it over and set it down again. So I had to regroup, take the platform apart a little bit, get it down a ways, in this case 6 inches, and then sort of fake the actual rigging in order to get clearance on the lift. Desperate times, desperate measures, I guess. So the next video in this series is going to be lighter work, fussier work, work that just has to be pretty darned accurate for a fabricator like me, and so, good luck with that, Wadsworth, but I think we'll be okay. And in the meantime, before I sign off here, I just want to let you know that we have developed something that we're very proud of. It's called the Essential Craftsman Academy. It's a subscription group, and it has lots of special and dedicated content that's only available inside the Academy. It's got courses and curated video lists for your employees. It's got ebooks that you can get a hold of that are part of the membership that you can read about hiring contractors. It's got a blacksmithing course. And the part that I enjoy the most is something called Shop Talk, where twice a month we all get together in a Zoom meeting and everybody talks about their projects and asks each other questions. The questions I can't answer, and there's plenty of those, believe me, are always fielded by some other expert who's just part of the community. It is, I think, the best resource for learning and getting a hold of the best information from the widest assortment and sort of group of people who have real-world experience that a guy's going to find. Besides that, it's show and tell. And who doesn't like show and tell? Check it out. Check out our website. You'll see how to learn more about the Essential Craftsman Academy. But in the meantime, thank you for watching Essential Craftsman, and keep up the good work.